Okay, everybody, getting ready to do lesson 11.7 of Pre-Algebra Math Part 1. Today we have a 38-point skill sheet in class work today. And we have 0 points of note-taking. It's about combinations today. Here is your standard combinations and probability. Teachers, this is the bell work for today. We've got a multiple choice thing here, and then down here make a stem and leaf. So that's going to take some time. If you need extra room, students, to make your stem and leaf, add a sheet to this classwork. And if you're online, make sure you take a picture of that, include it with your classwork sheet. I'd give your students 8 minutes to do this. Okay, welcome back for the solutions here. Here's solution for number 1. 8p3, and then this is the formula here for permutations, and you come up 336 here when you do your canceling. The horses can finish in first, second, and third in 336 ways. And then our stem and leaf down here, WG, and then our stem and leaf would be this. Here's your key. This is all important here is your key, students. If you don't have this, make sure you copy this down so you get credit for it. But that would be your stem and leaf for this data set. Okay, today you use permutations to count possibilities. You'll use combinations to count possibilities. We've done this before. We're going to use combinations now. A basketball league has 5 teams. 2 of the teams are chosen to play one another. How many different possible matchups are there? How will we figure that one out? A combination is a selection of objects where the order in which the objects are chosen is not important. So order is not important for a combination. In the problem above, suppose team A and team B are the 2 teams selected to play one another. It does not matter if team A is chosen first or if team B is chosen first. The same game will be played. So it's not really as important. So example 1 here, list and count different possible matchups for the basketball team described above. So you use letters A, B, C, D, and E to represent 5 teams. List the possible matchups here, then cross out any duplicates that represent the same matchup. So here would be the matchups here for A, B, C, D, and E. So these will be crossed out because they're the same, and then you end up with this amount here. D, E, E, D, these are the same here. But here are your fresh matchups here. So that would be what you would count. D, E, and E, D are duplicates because they represent the same matchup, yeah. So there are 10 different matchups. So you got your 10 here. So knowing that, you want to buy 4 different CDs. You can only afford to buy 3 of them. How many combinations of CDs can you buy? This is yours down here, students, so pay attention up here. So we make a list here, 4 different. We go A, B, C, and D to represent 4 CDs. We cross out duplicates, and we're left with the non-duplicates here. So you can buy 4 different combinations of CDs. Here's one here, here's another, 2, 3, and then this one, 4. That's kind of like the longhand way of doing it. You know the combination formula, students, so use it down here. Okay, relating combinations and permutations. Before matchups are crossed out, the list in example 1 shows the permutations of 5 teams chosen 2 at a time, or 5p2. After the duplicate matchups are crossed out, the list shows the number of combinations of 5 teams chosen 2 at a time. This written as 5 choose 2. Notice that in this situation, 5 choose 2 is 5p2 over 2 factorial, which is the following. Define the number of combinations of n objects taken r at a time. Divide the number of permutation of n objects taken r at a time by r factorial. So you have 9 choose 5. So you have this situation over 5 factorial, or n choose r, np r over r factorial. So that's our formula there for combinations. Book reports, you need to write 4 book reports for your English class. Your teacher gives the class a list of 7 books to choose from. How many different groups of 4 books can you choose from the list? So this is what we come up with here, 7 choose 4. We need to choose 4 books. So to find a number of different ways to choose 4 books from 7, we have this formula here, 7 choose 4, 7p4 over 4 factorial, which comes out like this, 7654 factorial. These will cancel. 7p4 and factorial is products. So what actually happens here is 4, 3, 2, 1, and then these will factor out here. What they do here is they factor this times this out, which is, they shouldn't do that, but they did. So anyway, we're left with 7 times 5 is 35 here, is what we end up with. So there are 35 different combinations of books, and that'd be using your combination formula here to figure a problem out like that. So we have the situation here, 6 choose 3, and then 4 choose 4. So for our guided practice here, this would be our situation here. So we have 6p3, so it'd be 654 is 6p3 is 654 over 321. And so they factor this, and they leave a 2, and then they factor this out, that leaves a 2. So we have 2 times 5 times 2, which is 20, is what that means. Students, this is yours here. And that is 11.7. Part 1, Part 2, Part 3 is available at that email. Email me, I get those out to you. Thank you.